a seed, not technically even a grain, that contains all 9 essential amino acids your body cannot produce on its own. Something that rice completely lacks. Something wheat cannot offer without heavy processing. And this seed has been quietly feeding entire civilizations for over 7,000 years, long before modern nutrition science even existed. The Inca people of South America called it Chizia Mama, which translates to the mother of all seeds. They considered it so sacred that their emperor would plant the first seeds of each season using a golden ceremonial shovel. Spanish conquistadors, threatened by the power this crop gave indigenous communities, actually tried to ban its cultivation in the 16th century. They burned fields, they forbade its planting, and yet it survived. Because you cannot erase a plant this resilient, this nutritious, or this important to humanity. That seed is quinoa. Quinoa's full scientific name is Chenopodium quinoa. It belongs to the family Amaranthaceae, the same broad family that includes spinach, beets, and chard. This is critically important context. Quinoa is not a cereal grain. It is a pseudo-cereal, a flowering plant whose seeds are used exactly like grains, but botanically, it is more closely related to leafy vegetables than to wheat or rice. The plant itself is remarkable to look at. It grows as an annual herbaceous plant, typically reaching heights of 1 to 3 meters, sometimes taller in ideal conditions. The leaves are broad, flat, and slightly waxy with a grayish-green color. The stem is thick and rigid, often tinged with red, purple, or yellow depending on the variety. But the most visually stunning feature is the seed head, called a panicle, which bursts from the top of the plant like a dense cluster of tiny orbs, ranging in color from creamy white to deep red to jet black, depending on the cultivar. There are over 3,000 known varieties of quinoa, developed across millennia by Andean farmers through careful selection. The most commercially prominent are white or ivory, red and black quinoa, each with slightly different textures, flavors, and nutritional profiles. What makes quinoa truly rule-breaking among food plants is its complete protein profile. Most plant foods are deficient in one or more essential amino acids. Quinoa contains all 9, including lysine, which is critically low in most grains like wheat, corn, and rice. This makes it functionally equivalent to animal protein in terms of amino acid completeness, a virtually unheard-of quality in the plant kingdom. Quinoa also has a natural coating of saponins, bitter, soapy-tasting compounds on the outer seed hull that serve as a natural pest deterrent. This is part of why the plant needs so little chemical protection in the field. Before eating, seeds must be rinsed or processed to remove saponins, but this also makes quinoa naturally resistant to insects and birds in the field, a remarkable evolutionary adaptation. Quinoa is one of the most climatically resilient food crops ever domesticated by human civilization. Its origin is the Andean highlands of South America, specifically the Altiplano, the high-altitude plateau region spanning modern-day Bolivia, Peru, Ecuador, Chile, and Colombia. This is a landscape of extremes: thin air, intense solar radiation, frost at night, scorching heat during the day, poor rocky soils, and very low rainfall. And yet quinoa not only survives here, it was bred to thrive here. The crop grows optimally at altitudes between 3,000 and 4,000 meters above sea level in its native Andes. However, modern research and global agricultural programs have successfully adapted quinoa to grow at sea level and across a wide range of latitudes, from Scandinavia to the Sahara fringe zones. In terms of temperature, quinoa prefers a range of 15 degrees Celsius to 20 degrees Fahrenheit to 68 degrees Fahrenheit during the growing season, but it can tolerate frosts as low as -8 degrees Celsius, 18 degrees Fahrenheit, at certain stages of development, an extraordinary cold tolerance rare among food crops. Conversely, some varieties can handle heat up to 35 degrees Celsius, 95 degrees Fahrenheit, for short periods. Soil requirements are minimal compared to most food crops. Quinoa grows well in sandy loam, clay loam, and even saline soils with pH ranging from 4.8 to 8.5. It has a demonstrated tolerance for soil salinity that far exceeds wheat and most other cereals, a property that makes it genuinely valuable for degraded agricultural lands. It also requires relatively low nitrogen, meaning it can be grown on marginal soils without heavy fertilization. Water needs are modest. Quinoa requires between 300 to 500 of rainfall per growing season, less than rice or maize. It is highly drought-tolerant once established, though consistent moisture during germination and early growth greatly improves yield. Today's top-producing countries are Bolivia and Peru, which together account for roughly 80 to 90% of global quinoa production. Bolivia's Salar de Uyuni region, the world's largest salt flat, produces some of the most prized royal quinoa in the world. Other significant producers now include Ecuador, the United States, Colorado and Washington State, Canada, France, the Netherlands, India, and Kenya. The crop is being actively developed across sub-Saharan Africa as a food security solution. Now, the growth timeline. Let's walk through it week by week. Days 1 to 5, seeds germinate quickly in moist soil at temperatures above 7 degrees Celsius. Germination rates are high, often 85 to 95% under good conditions. Seedlings emerge with two small seed leaves. Weeks 2 to 4, the true leaves develop and the plant establishes its root system. This is the most delicate phase. Seedlings are vulnerable to frost and waterlogging. Weeks 4 to 8, rapid vegetative growth. The plant shoots upward, producing its large waxy leaves. This is when the characteristic red-tinged stems and multicolored foliage become visible on many varieties. Weeks 8 to 14, the plant begins to flower. The panicle, the flowering seed head, emerges from the growing tip and elongates. Small, inconspicuous flowers appear across the panicle. Quinoa is primarily self-pollinating, which simplifies seed saving enormously. Weeks 14 to 20, seeds develop and mature. The leaves begin to dry and fall off as energy redirects into seed filling. Seed color deepens, and the plant transitions to a dry, papery texture. Harvest, approximately 90 to 120 days after sowing. The panicle is ready when seeds are firm, don't easily crush between fingernails, and have a moisture content below 12 to 14%. Harvesting is typically done by cutting the whole panicle and threshing. For home growers and container gardeners, quinoa is very doable. Dwarf varieties developed for temperate climates can be grown in large containers at least 30 to 40 centimeters deep in a sunny location. It actually makes a visually stunning garden plant with its colorful seed heads. Per 100 grams of cooked quinoa, you receive approximately 120 calories, 4.4 grams of protein, 21 grams of carbohydrates, 2.8 grams of fat. But raw nutritional numbers only tell part of the story. What sets quinoa apart is the quality of those nutrients. As already mentioned, quinoa is one of the only plant-based complete proteins containing all 9 essential amino acids in biologically meaningful quantities. The lysine content in particular, approximately 0.4 grams per 100 g cooked, is significant because lysine deficiency is linked to impaired calcium absorption, weakened immune function, and slower recovery from illness and injury. Most cereals are deficient in lysine. Quinoa is not. Quinoa contains meaningful amounts of iron, approximately 2.8 milligrams per 100 g cooked, supporting red blood cell production. It also delivers magnesium, 64 milligrams per 100 g cooked, which plays roles in over 300 enzymatic reactions in the human body, including blood pressure regulation and blood sugar control. Zinc, 1.1 milligrams, phosphorus, 152 milligrams, folate, 42 mg, and B vitamins, including B1, B2, and B6, are also present. Quinoa is naturally gluten-free, confirmed across multiple clinical studies, making it a highly valuable staple for people with celiac disease or non-celiac gluten sensitivity. The global celiac population is estimated at over 1% of people worldwide, and for them, quinoa represents a protein-dense, nutritious alternative to gluten-containing grains. The fiber content of quinoa, roughly 2.8 grams per 100 g cooked, rising to 7 grams per 100 g dry, supports healthy gut microbiome diversity, regulates bowel movements, and has been associated in peer-reviewed studies with reduced LDL cholesterol and improved glycemic response after meals. Quinoa also contains notable levels of quercetin and camphorol, flavonoid antioxidants that have been studied for anti-inflammatory, antiviral, and anti-cancer properties in laboratory and epidemiological research. These compounds are found concentrated in the outer layer of the seed. The glycemic index (GI) of quinoa is approximately 53, classified as low to medium, significantly lower than white rice (GI approximately 72), or white bread (GI approximately 75). This makes quinoa a sensible carbohydrate source for individuals managing type 2 diabetes or insulin resistance. For animals, quinoa has growing importance. The leaves, stems, and even the saponin-washed processing waste of quinoa are being studied as livestock feed supplements, particularly in Bolivia and Peru. The high-protein content of quinoa leaf meal makes it a viable partial replacement for soybean meal in poultry and pig feed formulations. An active area of agricultural research as soy prices and deforestation pressures mount globally. For the environment, quinoa offers multiple benefits. Because of its saponin coating and natural pest resistance, quinoa typically requires fewer pesticide applications than wheat, rice, or corn, reducing chemical load on surrounding ecosystems and waterways. Its drought tolerance makes it suitable for dry land farming systems that would otherwise remain unproductive. Its deep root system, roots can reach 1.5 meters, helps prevent topsoil erosion in sloped or marginal land. Quinoa also contributes to crop rotation diversity, breaking pest and disease cycles that affect monoculture cereal systems. The flowers of quinoa attract native pollinators, including bees and hoverflies, supporting local biodiversity on farms. Over 7,000 years ago, in the high mountains of South America, farmers without laboratories, without genetic sequencing, and without government agricultural subsidies bred and cultivated a food plant so complete, so nutritious, and so resilient that modern nutritional science continues to study it with genuine admiration. They did it through observation, through patience, through generations of selecting the best seeds and replanting them with care. That knowledge almost vanished when colonial powers tried to erase quinoa from Andean culture in the 16th century. It was only the preserved seed stocks held by indigenous farming communities, often in remote, inaccessible highland regions, that saved this crop for the world. Those seeds survived because people believed they were worth saving. Seed preservation matters more than most people realize. Quinoa's 3,000 plus varieties represent an enormous library of genetic diversity, varieties adapted to frost, to drought, to salinity, to heat, to high altitude, to sea level. Each variety lost is a biological solution to a future agricultural challenge, permanently erased. Organizations like the International Potato Center, CIP, and the National Institute of Agrarian Innovation of Peru, INIA, actively maintain quinoa seed banks for this reason. As a home grower or small farmer, simply saving your own quinoa seeds each season contributes, in a small but real way, to that global effort. From an economic standpoint, quinoa's global market has grown substantially over the past 2 decades. The global quinoa market was valued at over 1.5 billion US dollars as of recent estimates, driven by rising demand for gluten-free, plant protein, and health-focused foods in North America, Europe, East Asia, and Australia. For smallholder farmers in Bolivia and Peru, quinoa has provided a viable income crop where few others could grow. The export price of royal quinoa from Bolivia has ranged between 1,500 US dollars to 3,500 per metric ton, depending on grade and organic certification. Significantly more profitable per hectare than maize or conventional wheat in comparable soil conditions. In temperate regions like North America and Europe, domestically grown quinoa commands strong premiums at farmers' markets. And through direct-to-consumer sales, as buyers increasingly value local, traceable food sources. Certified organic quinoa attracts even higher returns. For anyone farming marginal, sandy or mildly saline soils where other crops struggle, quinoa deserves serious consideration. Let's bring it home. We covered a lot today. Quinoa is a complete protein, the only plant-based seed that gives your body all 9 essential amino acids it cannot make itself. It is gluten-free. It is rich in iron, magnesium, zinc, and antioxidants like quercetin and camphorol. It has a low glycemic index. It grows on poor soils with limited water. It resists pests naturally. It protects the topsoil. It feeds pollinators. And it has sustained human civilizations at altitudes and in conditions where almost nothing else can grow. This is not a trendy superfood. This is an ancient, battle-tested, science-confirmed food that modern agriculture is only just beginning to fully appreciate. If you have a garden, even a large container on a sunny balcony, quinoa is worth trying. If you are a farmer with marginal land and an eye on market demand, it is worth researching seriously. And if you are simply someone who wants to eat better, live healthier, and understand where your food comes from, quinoa deserves a permanent place on your plate. Nature gave us this seed 7,000 years ago. The least we can do is grow it, eat it, and pass the knowledge forward. If this video gave you something valuable today, a new perspective, a real fact you didn't know before, please share it with someone who would appreciate it. Hit subscribe if you want more research-backed deep dives into the world's most important plants, and leave a comment below. Have you ever grown or cooked quinoa? I'd love to know.